Hey everyone, so I just realized that I forgot to start the Zoom recording for the first like 10 minutes of class. So for the lecture, I wanted to make sure that you had a video where I did explain what was going on to kind of, so it would make sense. So we started class by talking about this problem that you see on the screen right here, which was a chemical reaction problem. So I'm just going to talk through the first part of this. The latter half of it is in the other video, so I won't do the whole thing. But so we have a photosynthesis reaction, and um, let's just look at the what you see on the screen right there. Okay, so I wrote the reaction down, and when I started, I didn't have anything in these boxes. Okay, so all these boxes were empty, and I had to assign a target, what we call a target molecule. And so my choice of a target molecule, I can actually choose any one of these four. It doesn't matter which one you choose. And the idea is just we're going to pick one of them to be one, and then we're going to say how much of the others do I need to have in order to make one of this. So in this case, I chose the glucose to be the target, and so I put the 1 right here. But you don't have to. But that was my choice. I chose the biggest molecule just because I thought it might be easiest to get that one out of the way. And then I'm going to let my variables x, y, and z, that's going to be like how many molecules do I need of carbon dioxide, and how many molecules do I need of water, plus however many molecules I need of oxygen in order to make one molecule of C6H12O6. Okay, so then the next step is that we write these element equations, and I need 3 equations because I have 3 variables. So I have x, y, and z, so I need 3 equations for 3 variables. All right. What you see now is the actual element equations that we wrote from that original reaction. So let me copy that over so we can compare it. So we've got, oh, I'm sorry, here it is at the top. This is the original reaction right here. This is the original reaction. And then I've got my 3 element equations. So for carbon, we look through and we say, okay, so how much pure carbon is contributed by each compound? The first CO2, it has 1 carbon for every X molecules, right? Each molecule has 1 carbon atom. So that's X times 1. So that's where the 1X comes from. For oxygen, there is no carbon, so we have 0 Y. And there are 6 carbons in a glucose molecule, so that's 6 times 1. And then there are 0 carbons in the oxygen, so that's why you have 0 times Z. Then for the pure oxygen equation, how much pure oxygen is contributed by each compound? We have 2 atoms for CO2 times X, hence 2X. 1 atom in H2O times Y. And then 6 times 1 for glucose, and 2 atoms times Z for oxygen. All right. And then similarly for hydrogen, we have 0x plus 2y, 2 here, y, then 12 atoms plus 0z. And so all of that together makes my system. Over on the right-hand side of the screen, I kind of rewrote my system in a more orderly form, and I moved everything over to the right-hand side or the left-hand side except for my constants, which generates this matrix: 1, 0, 0, 2, 1, negative 2, etc. and then we solve that matrix. We put that into the calculator, and we get our solution, which is x, y, and z are all equal to 6 in this case. And so our balanced chemical equation is shown here. Okay. So I believe that is pretty much all that we were doing in the first part of class there. So this should catch you up to, now you can kind of start watching that video and see the rest of it. Okay. Thanks.